Okay, here we're going to solve two equations. One of them is an equation involving rational expressions, and another one is an equation involving quadratic expressions with absolute values. So let's jump into this one first. So my strategy whenever solving rational equations is to get rid of the denominators as quickly as possible. And since we have this nice setup where we have a fraction on one side and then a fraction on the other side of the equation, we can do that just by cross multiplication. So I'll multiply this 1 up here, and then I'll multiply this denominator up to the right hand side. So in other words, the t squared plus t minus 2. So let's see what that gives us. So if we multiply 1 up here, well, that doesn't change anything. So we've got t cubed minus 2t plus 1. Then we multiply t squared plus t minus 2 up to the t. So that's going to give us t cubed plus t squared minus 2t. So something like that. Now, what I want to notice is that I can cancel some stuff out at this point. Notice I can subtract a t cubed from both sides of the equation, and those cancel. And then furthermore, I can add a 2t to both sides of the equation, and these two cancel. And that just leaves me with t squared and 1. So in other words, I have reduced this to the equation t squared equals 1. But if t squared is equal to 1, taking the square root of both sides, or maybe moving the 1 over and factoring, either way we do it, we get t equals 1 or t equals negative 1. But in fact, we're not quite done, because whenever we have an equation involving rational expressions, we have to check that our solutions did not cause zeros to appear in the denominator of our original equation. So notice in our original equation, we only have one thing in the denominator. That's this t squared plus t minus 2. So we need to check if we plug t equals 1 into this, do we get 0? If we plug t equals minus 1 into this, do we get 0? Well, let's maybe first plug t equals 1 into this. So plugging t equals 1 into this denominator gives us 1 squared plus 1 minus 2, but that's equal to 0. But since that's equal to 0, we can't really have zeros in the denominator. That doesn't make any sense. So that means we cannot keep that solution. So let's look at this other one. So plugging in t equals minus 1, let's see if that's okay. So that's going to give us minus 1 squared plus minus 1 minus 2. But notice this thing is okay because we'll get minus 1 squared, which is 1, and then minus, so this is going to be 3, so we get negative 2. So in other words, we are able to keep this one. So this is our solution, t equals minus 1, and in fact, our only solution. Okay, so now let's move on to this next one. So here we're looking at the absolute value of 2x minus x squared equals the absolute value of 2x minus 1. Now here we're going to use the following fact, that if we have the absolute value of a equals the absolute value of b, then that means that we have a equals b or a equals negative b. So you can take this absolute value equation and split it into two equations without absolute values. So let's go ahead and do that. So we'll split maybe the plus over here and the minus over here. So along the plus direction, we get 2x minus x squared equals 2x minus 1. And then along the minus direction, we get 2x minus x squared equals minus 2x minus 1. Okay, good. So now let's go ahead and simplify this one. So notice to simplify this one, we can cancel the 2x on each side because they have the same coefficient just by subtracting 2x from both sides. Then maybe we can move this x squared over, and that's going to reduce this to the equation x squared minus 1 equals 0. We can go ahead and factor that to x minus 1, x plus 1 equals 0 because we've got a nice difference of squares there. But that tells us that x equals 1 or x equals minus 1. So there we've got two solutions. And then it's straightforward to check that both of those solutions satisfy the original equation, so we're okay. So now let's go into this next equation. So we've got 2x minus x squared equals negative 2x minus 1. So maybe the first thing that we'd like to do is distribute this minus sign through to each of the terms. That gives us negative 2x plus 1. Now we can move some stuff around. So maybe what I would like to do is add an x squared to both sides and subtract a 2x from both sides. So let's see what that gives us. Over there on the left-hand side, everything's going to cancel. So we'll be left with 0 on the left-hand side. I'm going to swap the sides of the equation to make the left-hand side the right-hand side. So we've got 0. And then on the right-hand side, we get whatever we have from combining those 4 objects. So notice we'll have x squared, and then we'll have minus 4x, and then we'll have plus 1. So we've got something like that. Now, the first thing to do is maybe try to factor that to find a solution, but I think you can immediately see that that's going to be hard to factor. So our next bet is to look at the quadratic formula. So we'll have x equals negative b, so that's going to be the opposite of the coefficient of x, so that'll be 4, plus minus the square root of b squared, so that's going to be 16, minus 4 times a times c, so that's 16 minus 4, all over 2, like that. Then we can see that 16 minus 4 is 12, which equals 4 times 3. It's important to do that because 4 is a perfect square, so we can pull it out. So if we pull the 4 out, we will be left with just 3 on the inside, and then taking the square root of 4, we'll have 2 on the outside. So after canceling with the 2 in the denominator, that's going to give us 2 plus minus the square root of 3. So notice we've got this 4 divided by 2 is 2, and then this 2 divided by 2 is 1. So that's what we get there. Those are 2 more solutions if we wrote them like x equals 2 plus root 3 and x equals 2 minus root 3. So all in all, we've got 4 solutions to this equation, and that's a good place to stop.